Hi, welcome back to Science 1206, the Weather Dynamics Unit. I'm Miss Ledwell, and in this video, we'll talk about Earth's spheres. Let's get started. Earth is composed of many interactive spheres that interact with one another. Energy from the sun drives many processes affecting Earth's spheres, which include the lithosphere, or the land. This is made up of land-forming continental crust above sea level and oceanic crust at the ocean bottom. In this diagram to the side, we see the lithosphere is labeled, and in this instance, it's pointing to continental crust, crust above sea level. The atmosphere is all the air surrounding the planet. The atmosphere consists of nitrogen, oxygen, and other gases, and extends more than 700 kilometers above Earth's surface. The first 12 kilometers of the atmosphere is known as the troposphere. The troposphere is the region in which all weather takes place. And in our diagram, we see the atmosphere, the air surrounding the planet, labeled. The hydrosphere, or water, is all of the solid, liquid, and gaseous water on Earth, including water in the atmosphere and lithosphere. It includes water vapor, rain and snow, oceans, lakes, rivers, ice sheets, and glaciers on the surface of Earth, and groundwater in the lithosphere. In our diagram, the hydrosphere is labeled. In this case, it's pointing to all the oceans on Earth. The biosphere, or life, encompasses all regions on and beneath the lithosphere, within the atmosphere, and throughout the hydrosphere that support life and are inhabited by living organisms. In our diagram, you can see the arrows pointing to the green area on the continent. This indicates plant life, and it's the biosphere. The interaction between solar energy, the energy generated by the sun and given off in all directions, and Earth's spheres, the atmosphere, lithosphere, hydrosphere, and biosphere, is fundamental to understanding weather dynamics. The diverse weather patterns we experience are directly linked to how the sun's energy interacts with Earth upon entering its atmosphere. Solar energy travels from the sun to Earth through radiation. Radiation is a type of thermal energy transfer in which atoms or molecules give off energy in the form of electromagnetic waves. Electromagnetic waves, you may remember from grade 8 science, carry the energy from the sun through space and release the energy when they interact with some form of matter, such as the ground, water, or air. Electromagnetic radiation is the transmission of energy in the form of waves that extend from the longest radio waves to the shortest gamma rays. Longest radio waves and shortest gamma rays are referring to the wavelength of these forms of electromagnetic radiation. Compared to other types of electromagnetic radiation, radio waves have the longest wavelength and gamma rays the shortest. This diagram shows the electromagnetic spectrum. We can see on one end of the spectrum are gamma rays. They have the shortest wavelength. And on the other end of the spectrum are radio waves, which have the longest wavelength. Also notable on the electromagnetic spectrum is the visible light spectrum, and you'll see that that falls between ultraviolet light and infrared. The electromagnetic spectrum shows the range of all the types of electromagnetic radiation, arranged according to wave frequency and wavelength. This diagram shows an example. Again, we see on one end of the spectrum where we have the longer wavelength are radio waves. The examples they use in this diagram are AM radio and amateur radio. And on the other end of the spectrum, with the shorter wavelength, are gamma rays. The types of electromagnetic radiation that make up the electromagnetic spectrum, listed according to decreasing wavelength and increasing frequency, include radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. Radiant energy can interact with matter in different ways. It can be absorbed, or reflected. When radiant energy is absorbed, the waves or energy are taken in by an object. The object becomes warmer. For example, a stretch of pavement absorbs sunlight and heats up on a sunny day. When radiant energy is reflected, the waves or energy bounce off the surface of an object rather than being absorbed. For example, light-colored surfaces, like a white sandy beach, reflect the sun's rays. Now it's time to continue to the next video. Take a 30-second break, stand up and stretch, then continue on to the next video.